results. So just to trying to involve students in a mathematical way, but also in a playable way of dealing with that. Afterward, when I came back here to Austria, I started to develop some or design some activities in combining this physical and digital approach, and some of them is regarding this dissection of cube. So we tried out so far in a few workshops, but something that it came in my mind is this really nice opportunity to discuss some concepts about infinite geometrical constructions as well, and the 3D transformations. On the one hand, exploring it in a physical way, students can match the pieces and compare the volumes or surface area, but also in a digital way, they can properly see the transformation behind that regarding the symmetry or rotation and so on. Something that I got in Italy in a museum there in Cecilia. It's this experiment based on Archimedean Principle to show the equivalence of the volumes of the sphere and the cone and the cylinder. So, so I was wondering how could we implement that or bring to the school this kind of models. So the original experiment that I saw there, it was like big like that, and I just adapted in a really small sample. But also I was looking for some digital materials regarding to that. So again, we could explore some properties regarding the integral idea, for example, or the infinite slice to think about that and to promote this conjecturing process. The Cavalieri principle and so on. Still in the same field or the same idea, I have developed this material. Thanks for Martin to collaborate with his nice face, but unfortunately, whoa, it was failing somehow. Let me try again. Well, sorry, it's not working here, but I have a link in the end to this material online, so you can explore. I'm basically showing how it works in this sense of the rotating the profile curve and generating this vase. So digitally you can properly observe the transformation behind, but also if you go to the link in the end I'm sharing with you, we can, oh, I didn't bring the physical one. We can explore some salt inside or something like that. I can share with you in the end. Then I have collected during this time some ideas and inspiration from some colleagues who are also working with that. So I have to strongly mention this one. Maybe it was my first motivation for that. A colleague of mine in Brazil was doing this quadric surface. He started with that in 2015 when we got a 3D printer there first time. And he was designing these models with our prospective teachers and students in our institution. But also I have collected some other experiments from South America as well, from Laura in Argentina. She's doing some experiments with calculus, and also Gustavo Aguilar, who presented yesterday. He's designed some algebraic surface and also printing out as he showed yesterday for us. Another approach that I have developed with a colleague of mine in Canada, Marina Barreto, it's using these spirals to push students again in this creative way, but also concerning math in these mathematical or geometrical constructions, but not only restricted to that. If we are looking at this material carefully, we can see different perspectives in using that. for example, regarding fractions or series, the infinite sum of these similar triangles. Also about this 2D and 3D transformation, how could we move from 2D to 3D? And for example, this Euler's formula, if we are exploring it physically. Some other experiments with tessellation designed by Cecilia Russo. It's also exploring this transformation even more in 2D. But something nice that it would be nice to observe here is exploring patterns. How could be fruitful for students if they observe, for example, here we have two different patterns with the same area and same perimeter. And here we have still the same area, but not the same perimeter. So these kind of questions, it would be nice to explore with the students in a practical way and playing with this material. Some idea that Julia brought or gave to me once about this Viviani's theorem. It's a really nice problem in math that could be motivating this conjecturing or argumentation process to explore it. But from my perspective, they have different approaches in physical and digital way as well. So Renata is also starting right now with some experiments using 3D and printing and digital design. She's developing some materials on GeoGebra as well to promote spatial reasoning and visualization. I'm out of the time, but I'm almost finishing. Sandy from Austria here as well. She is designing or developing some activities with Voronoi diagram. So, but also connecting with the digital approach, she is considering some perspectives in using that in another kind of fields, not only in math, but in natural science, for example, and some optimization problems. The last one is regarding this daily life demand. So modeling for really fix some problems that we have at home for like that, fixing a lamp or a suitcase. And finally, well, we have some discussions here. Maybe just to highlight my main motivation in doing that is pushing students in this making process even more than playing with that or interacting. It seems to me when they are modeling or constructing these applets or objects, I mean, even in their mind, they carefully think about math and so on. So, yeah. And then I took some considerations about physical and digital world. And if you want to follow these online materials, you can just track this QR code. Thank you for that. And I'm glad to.
Keep the code there, it was so short time.
Okay. I should keep in the last line.
So I have to go to the center, but I think the center break.